Hi everyone, this is Julia. So today I'm going to go over Spring 2018's midterm exam. So I hope that in doing the exam, you'll find that it's pretty good preparation for your exam this semester, which is Spring 2019, because Professor Freeland also taught in Spring 2018. Alright, so let's just get started. In this very first part, we're just going to talk about the short answers on this page. So question 1. In general, recursion is more powerful than a for loop. Explain why. Okay, so the answer to this is false, and I'll explain. In this question, we're comparing recursion to a for loop, and it's just not a fair comparison because all recursive solutions can be turned into iterative solutions, and vice versa. So if we had a function, let's say factorial, it's really common to do this with recursion, but it's also easy to turn the recursive solution into an iterative solution. So if you're interested, you can look up the two. And in homeworks and labs, you might have redone an iterative function as a recursive one. Anyways, the point is that one can be turned into the other. So it's just not fair to compare them because they are essentially the same sort of solving technique in the end. Like, they have the same correctness, and it just takes some modification to turn one into the other. Right, so this is false. Okay, question 2. A function does not allow repeated execution of statements. Explain why. So to answer this question, I want to, go back and think about why we learn functions in the first place. Why we even have them. And the answer to that is that functions should do something for us well, do one thing for us well, and it should do it many times. So it doesn't really make sense to make a function that we only call once, right? It's kind of a waste of time to just do one thing once when we could just, do it. And to put this in more concrete terms, think about the max function. So you take in a sequence and you return the max value of that sequence. And you can imagine that max is called millions and millions of times across all Python users. And that's because this function is really useful, and we want functions to be super useful. We want them to repeat the series of steps over and over again for different inputs. So the answer to this question is false because it defies what a function is really for. We want functions to repeat steps and apply the same process to different inputs. Alright, so this is false. Okay, so number 1, I'm just going to briefly go over this, but the answer to number 1 is an iterator. So we haven't covered iterators yet. We're going to get there, so don't worry about this for now. Number 2, the answer to this is an operator. So this is just a fancy word for, something you apply like a function. If you remember when we were talking about call expressions, we said that if you have something like min of 2 and 3, this is considered to be the operator, and these are considered to be the operands. So manipulate a literal is sort of a fancy way of saying that the operand is doing some change to the operator is doing some change to the operands. So what min does when you apply it is it looks at both of the elements, both of the operands, and then takes the smaller one. So that's operator. Okay, so number 3 is abstraction. We talked about this kind of briefly, but abstraction you can think of as, in computer science, we don't need to know the full details of something in order to use it or in order to have it work for us. Perhaps we might give you a function on an exam or in a project, and we don't actually tell you how we code it or how it's implemented at all. So you don't know how to make that function, but you know how to use it in your code. So that's abstraction. Sort of when we say shielding a user from a concrete implementation, we're not bogging you down with the details of how it's made. We just let you use it and tell you how it should behave. Alright, so that's number 3. And number 4 is C, just by process of elimination. But higher order functions directly match this definition. So by definition, higher order functions are functions that take in functions as input, or a function as input, and they return a function as output. They could do one or both or something like that. Alright, so moving on to number 4, I'm actually going to cross this question out. We haven't covered runtime in this class, so don't worry about this one. Although I do recommend that if you're interested, you should definitely look up runtime and how to analyze a code block's runtime. It's a really useful skill, it's really interesting, and it's studied very extensively and widely. Alright, so last question, number 5. Provide 2 practical reasons why Python allows to define a function within a function. Alright, so what does this even look like? Well, it sort of looks like something like this, right? Blah, blah, blah. Blah, blah, and then blah, 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 right? So we have nested functions. Okay, so one reason is that we want our code to be more complex, to be more powerful. And anytime where we use like a chain of functions, or like a function inside a function, or a higher order function, this is always going to make our code less simple, more powerful, just we are able to do more things with it. And another reason is that you might only need this function for the outer function. So let me repeat that. The inner function may be only used in the context of the outer function. So let's say if I call this outer function foo and this inner function bar, it could be the case that we never use bar except when we're using foo. So this lets us know that we don't really need it outside of our code to use for other things. It's just, it serves a special purpose for foo. And so this makes the code cleaner, and it saves space in the global frame. Another reason is that in Python, so many things are considered data types, and functions are one of them. So you can take in a function as input and return it as output, as you see with higher order functions. Alright. One last thing is abstraction. So like we talked about over here with abstraction, having a nested function makes your code more organized and makes it a lot shorter. So as I said earlier, that you have this sort of function inside of another function, and with that, you're showing yourself and other people who might look at your code that this function and this other function go together all the time.